Okay, so last time we talked about monads, and I mentioned at the end about something which is called applicable. It's not applicable. It's of course applicative. So applicative defines an apply function. You can call it apply because it can be confusing for Scala, so it will be apply function. And that I wanted to do is so this apply function with parameterizing a and b, and we are saying that the first argument is my nullary function a, but the second argument is also nullary function but giving me a and b, a to b, and as a result I would like to get nullary function which is giving me b. So the implementation is pretty straightforward because I have to get back again another function, and on one hand I will apply on the result of application of fab, fa. Yeah, so this is what applicative is doing. So for foo and for bar, okay, I can call apply foo bar. Yes, and I will get this result. So probably we have an X category applicative, but I'm not sure about that. Generally, we can say about category when we have a combiner, and we can use this combiner in an associative way. So we don't care about the order of application. So I have like, it's called map. Yeah, so I don't care if I do first these two operations or I do these two operations. Yeah, whenever I can do this, probably whenever you can do this with your combiners, probably you discovered new category. Okay, so today will be about arrows. And okay, so we created combiners which are able to combine nullary functions in some way. So in case of monad, we can combine also the functions which giving us back the nullary function. Arrows are the problem which are trying to solve binary and more n-ary functions. So arity of function is greater or equal to 2 to combine it. Looking at the signature, you are slightly, these of you who are not familiar with maybe with type categories, we are rather thinking in case when you are at school as something like f of x y or f of x y z. So instead of doing it in that way, we can treat this function as an f of x, of y, and of z. Yeah. So, and this is coming into y and z. Yeah. So this is like that. So when we think about arrow, so in that case we have case of arrow, we have something like we would like to do some operations on our n-ary function. So that what we want to do is like we would like to apply some function f on the first argument,
script.
So when I have a function fbc, and I would like to apply my f function to the first argument of my function, or I would like to apply the second argument of my function. So this time will be b to b. And now we would like to implement that using functions only, as I said. So let me define the first function, which is parameterized by abc, and two arguments. The first is my arrow, so my binary function. The second one is the function f a to a, and my result is function a b c. Yeah. So now how to do this? We can do this really very straightforward, because we know that we have and then combiner. So that's it, what we have to do. The second is a little bit more tricky. The first thing is that the first step will be to create a naive implementation, but still correct. Yeah. See, this time I have a GB2B, and I have a B, C. And in naive implementation, I have something like I get an A of type A and B of type B, and actually I'm applying them to my arrow. So the first argument, we will use this notation now. So my first argument is an A, and the second is G of B. Yeah. So, but instead of that, we can write this definitions, let's say maybe smarter way, or maybe shorter, surely shorter, not surely smarter. So I can compose my G function with my arrow, but with partially applied argument. So here I partially apply A argument. Yes, this is a type of A. So this creates me. This creates me. So I have a G. This creates me. So this one moves A in front of this all expression. And then I have a B function, so I have a B to C function, so I can apply G on B to C. Yeah, so this is exactly the same. So this A, this is this guy, which is coming in front of this thing as the first argument of that function. This guy is then reduced to, I will write it, to B to C. Yeah. And then I can apply G, yes, on this B, and this gives me again B to C function. So this is why it is working. So the first and last thing is implementation of triple stars, and triple stars is a function which is applying both first and second arguments on my arrow. So again, so naive but still good implementation is this guy. So I have arrow A to B to C, and F A to A, and G B to B. Of course, that I want to get is A, B, C. My naive implementation is A of A to B of B, and I call arrow with f of a, g of b. Yeah, but again we can do this in even more functional way. So instead of defining here inline the function, I can compose my functions with partial application. So I have to write like this, start like this, because there is a problem. I had a problem with it. So here I will use, to that definition I will use only first and the second function. So I will get a first function, and I partially apply the first argument, which is a to b to c, with my f, and then so I compose it with my second function, also with partially apply the first argument b. I'm writing here a signature not only for you but also for compiler. In other case we will get a compilation error that this type cannot be inferred. And then I apply all of this to my arrow. There is missing one. Yes, I see it. So this is incorrect. Sorry, I need to rewrite it. Here is missing one bracket. Okay, yeah, so the signature is pretty correct. How is this working? When we look at, I have here prepared two functions. So I have here a definition of the first function with f. This is my f, x, which increments x by 1. So this is how it is working. Yeah, so I have a from function which takes two arguments. I just create a function which takes this argument, this type. So I have here, and this first function is giving me back this guy. So, and similarly to the second, yes, similarly to the second. And now I can easily compose these two things. So I get a res10, and then res11, yeah, and it creates me a function which is getting an arrow and giving me back an arrow. So there is yet another function which is also used in case of errors. This is triple ampersand, but in that case it is pretty similar situation. The main difference is that instead of having a function a to b to c, this is actually the function which is getting which is copying the first argument. So it is a to b. And that's it. This is the end for this short introduction into categories with really simple functions. Yeah, we were talking about nullary functions, unary functions, and binary functions. Now we know how we can combine them. And every time we need something else, we need to probably try to define another combiner. We also know how to add this combiner in Scala, so usually we are creating a type class which are collecting these combiners. Here in case of arrows we have 3 of them, so we have 3 functions, first, second, and triple star. So these 3 functions can create a type class which can be applied to binary functions. And in the future I hope that you will discover your own categories if you will have such need. Thanks guys, and good luck.